Do you know? There is a planet out there that should not exist. Its surface is a global ocean of liquid rock. One side is locked in eternal fire, the other in permanent, absolute darkness. For decades, planetary science had a law, an ironclad law. Small, scorching planets, the ones baked by radiation for billions of years, cannot hold onto an atmosphere. The stellar winds are simply too ferocious. The gravity, too weak. The heat, too cataclysmic. Every gram of gas is stripped away and hurled into the void. In 2026, the James Webb Space Telescope stared at this world, a world called TOI 561b, for 37 uninterrupted hours. And what it found didn't just surprise scientists. It didn't just break a rule. It shattered our most foundational understanding of how atmospheres form, survive, and persist across billions of years. This is the story of the hell planet that rewrote the textbooks. 560 light-years from where you're sitting, a distance so incomprehensible that if you traveled there at the speed of light, every single person alive on Earth today would be dust before you arrived. There is a world unlike anything we have ever encountered. Its name is TOI 561b. It is a super-Earth, roughly twice the mass of our planet, 4 times its radius. But every similarity to home ends there, because TOI 561b orbits its star at a distance so primordially close, so unfathomably intimate, that it completes a full year in just 10 hours and 36 minutes. At that range, the star doesn't just warm the planet, it owns it. Through a phenomenon called tidal locking, the planet's rotation has been enslaved to its orbit. One hemisphere, permanently, eternally, faces the star, bathed in relentless radiation. The other side has never once seen starlight. It exists in permanent, absolute void. On the day side, temperatures reach 200 degrees Fahrenheit. That is hotter than molten iron, hotter than the surface of many stars. At those temperatures, rock doesn't just melt, it vaporizes. The entire surface of TOI 561b is almost certainly a single, planet-spanning ocean of liquid magma, kilometers deep, churning with incomprehensible geological violence. Its entire surface is likely a magma ocean, with gravity permanently locking one half of the planet in scorching starlight while the other side is stuck in the dark. By every exoplanet rule we thought we knew, it should be a bare rock. To understand why TOI 561b confounded every expert who studied it, you have to understand a fundamental axiom of planetary science, one that it held unbroken for decades of observation. Planetary scientists call it the cosmic shoreline. On one side of this boundary, worlds massive enough, cool enough, or far enough from their star to hold on to their gas. On the other side, barren, stripped, atmosphereless rocks. The physics is merciless. Stellar radiation, in the form of X-rays and ultraviolet light, bombards a planet's upper atmosphere and imparts energy to its molecules. If those molecules gain enough energy to exceed the planet's escape velocity, they simply leave. They are scattered inexorably into the interstellar void. For a planet like TOI 561b, small, scorching, irradiated since before our solar system even existed, the math was not merely discouraging, it was categorical. TOI 561b orbits a star that is approximately 10 billion years old. That is twice the age of our own sun. For 10 billion years, this world has been enduring a bombardment of stellar radiation that would eviscerate any conceivable gas layer. Mercury, which orbits our sun at 40 times the distance of TOI 561b from its star, barely has an exosphere, a wisp of atoms too thin to even measure as an atmosphere. And so, when the scientific team at Carnegie Institution for Science first began designing their observation program, the stated goal was modest. They didn't expect to find an atmosphere. They expected to confirm the absence of one, adding one more data point to the cosmic shoreline model that had governed exoplanet science for 20 years. They pointed the most powerful telescope in human history at this hellish little world, and they prepared to find nothing. JWST's observation of TOI 561b ran for 37 consecutive hours. During that time, the planet completed nearly 4 full orbits of its star. The telescope used its near-infrared spectrograph, an instrument of almost incomprehensible precision, to measure the brightness of the star-planet system as TOI 561b moved behind its host star. The technique is known as a secondary eclipse. When the planet disappears behind the star, its thermal emission vanishes from the data. What remains is the star alone. The difference tells you the temperature of the planet's day side. The model predicted a dayside temperature of nearly 900 degrees Fahrenheit. That was the number the cosmic shoreline demanded. That was the number a bare rock, stripped clean by 10 billion years of stellar fury, would produce. The data came back. The number was 200 degrees Fahrenheit. A difference of 700 degrees. On a planet that small, in conditions that extreme, after 10 billion years of radiation assault, that discrepancy is not noise. It is not a measurement error. That discrepancy is a declaration. Something is moving heat from the day side to the night side. Something is redistributing thermal energy across the face of this world. Something is there, between the magma and the void. An atmosphere. We think there is an equilibrium between the magma ocean and the atmosphere. At the same time that gases are coming out of the planet to feed the atmosphere, the magma ocean is sucking them back into the interior. This planet must be much more volatile rich than Earth. It's really like a wet lava ball. The mechanism that allows this world to survive its own star is, in itself, a phenomenon with no precedent in our solar system. The magma ocean, that kilometers deep sea of liquid rock, acts as a primordial reservoir. Volatile compounds, water vapor, carbon dioxide, silicate gases, are continuously exhaled from the churning melt below, replenishing the atmosphere as fast as stellar radiation tears it away. A cycle of cataclysmic rebirth, operating on geological timescales, has been sustaining this impossible sky for billions of years. Here is why this matters beyond a single data point from a single bizarre world 560 light-years away. TOI 561b formed in one of the oldest regions of the Milky Way, a dense, primordial zone called the thick disk, where stars formed when the universe was young and the raw materials of planets were chemically different from anything in our solar neighborhood. This planet may be a relic, a survivor from the earliest epoch of cosmic history. And it has an atmosphere. If a planet this hostile, this scorched, this ancient, this small, can sustain an atmosphere through the sheer geological tenacity of a magma ocean, then the cosmic shoreline has been drawn in the wrong place. Worlds that we had dismissed as dead and barren may, in fact, be exhaling. This census of potentially atmosphere-bearing planets in the galaxy just expanded dramatically. We are not, of course, suggesting TOI 561b harbors life. At 3,000 degrees, even the most extremophilic organism we've ever discovered would be reduced to its constituent atoms in microseconds. The hellish nature of this world is not in question, but the principle it has demonstrated. That magma oceans can sustain atmospheres across geological timescales, that life's prerequisite can persist in conditions we once called impossible. That principle now applies to millions of worlds we haven't yet examined closely enough to know. Lead researcher Dr. Johanna Teske of Carnegie Science said it best. What's really exciting is that this new data set is opening up even more questions than it's answering. That sentence, the hallmark of every genuine scientific revolution, is the legacy of TOI 561b. Not a clean answer, but a door, swung wide open, into a universe we understand even less than we thought we did. 560 light-years away, a planet sits in eternal fire, orbiting its star 12 times faster than Mercury orbits ours. Its surface an ocean of liquid rock, 1,000 degrees hotter than anything on Earth. It surrounds itself with an impossibly thin veil of gas, inhaled and exhaled by the very magma that should have annihilated it. And it has been doing this defiantly, silently, incomprehensibly, for 10 billion years. Before our sun was born, before our planet condensed from the dust, before life on Earth drew its first breath. The universe, it turns out, is far more stubborn than we gave it credit for. Subscribe Cosmir Tales for more.